So for this question, we are expected to expand and simplify x minus 1, x squared plus x plus 1. Okay, so for this is just a simple algebraic manipulation. So we just expand the expression. So first to one, we have x cubed. Let me just write out the question first. X minus 1 bracket with x squared plus x plus 1. Okay, so the first to the third, that gives us x cubed. X to x, that gives us x squared. X to 1, that gives us x minus x squared. Sorry, minus x squared, right? Minus x and minus 1. So you can see that the x squared terms cancel off. The x terms also cancel off. And we are just left with x cubed minus 1. Okay? Hence, or otherwise, show that there's only one root to the equation. X minus 1, x squared plus x plus 1 equals to 0. So for this question, I mean, it's quite easy. Okay, so you can see that if I equate x minus 1, x squared plus x plus 1 equals to 0. By the virtue of part 1, you know that the entire expression here can be written as x cubed minus 1 equals to 0. Okay, so what does that tell you? Well, if you try to solve for this, right, you know that there will only be one answer. So if you put x squared equals to 1 and you cube root both sides, all right, the only answer that you get is x equals to 1. Okay, so this one, if you put 1 to the right hand side and you solve this as a cubic equation, the only answer you will get is x equals to 1. There cannot be any other answer. Okay, all right. You can even use the calculator to test this out on your own. All right, of course, the calculator method will not be shown. Right, you cannot show it. All right, so another method, if you're not convinced, right, is you can also do what we call the discriminant method. Okay, so if you take x minus 1, this is the otherwise method. So this is the hence method that I use part 1. Of course, there's an otherwise method. The otherwise method is that if you use x minus 1, x squared plus x plus 1 equals to 0. If you want to show that there's only one root, you can see that this will basically, if you equate to 0 by the 0 product rule, it will mean that x minus 1 equals to 0 or x squared plus x plus 1 equals to 0. Okay, this is by using the 0 product. Here, the left-hand side, x equals to 1. And for the right-hand side, you will find that this does not give you any solution. Okay, whether you use completing a square or quadrant formula. So how do you show it fast that this has no solution? The easiest way is just to use discriminant. Okay, so you have observed the discriminant. A, okay, you see, A is equals to 1. B is equals to 1. C is equals to 1. Right, the discriminant is b squared minus 4ac, which gives you 1 minus 4, negative 3, less than 0. So you can see that for the second quadratic expression, there are no real roots. Okay, so the only answer is that, hence, x equals to 1 is the only real root. This is the otherwise method. I basically did not use my result from part 1. All right, so this is the otherwise method. Okay.